Bitcoin has always sort of surpassed expectations. It's now at $100,000.
Yep.
We have NFTs on Bitcoin called ordinals, and you're betting that Bitcoin has ZK rollups.
Yes, exactly.
Why?
I'm not betting Bitcoin has ZK rollups, but I'm saying that Bitcoin needs ZK rollups. There are a couple of reasons behind. The first is obviously the security of Bitcoin is very important. Like most of the chains bootstrap their own validator set or own miners, but none of them are even close to Bitcoin's hash rate and the security. Bitcoin blockchain has been live for more than a decade, and that's definitely important. Lots of projects try to borrow security from Bitcoin by sending some hash to Bitcoin, or like trying to do Bitcoin staking with some like additional economic security. But with rollups, you have this thing where you share the same data availability layer, which in our case it's Bitcoin, with the main chain, so that you get majority of the security from Bitcoin main chain without trying to do anything or try to change the protocol. So by basically rollups share the same data availability and consensus layer with the base layer, which is Bitcoin, so that they get the reorg resistance, they get the censorship resistance, they get the double spending resistance. So these are like the most important properties of a blockchain that should have, and Bitcoin is the perfect place to do it. That's one reason. And the second reason is people actually want to use their Bitcoin. We realize that together with ordinals, even though it's just like meme coins and stuff, people actually use Bitcoin, and they want to use Bitcoin even though the user experience is awful. They still use ordinals, BRC20s and runes. So this definitely shows a demand, in addition to all the WBTC and Coinbase BTC stuff happening on Ethereum. But currently the only way of using Bitcoin in DeFi is just trusting some custodians like BitGo, like Coinbase, to simply represent your Bitcoin as a ERC20 on Ethereum. And we want to change that by basically enabling the most trust minimized version of Bitcoin in an EVM ecosystem. In addition to that, that ecosystem is fully Bitcoin secured with the properties that I listed as like double spending resistance, reorg resistance, and censorship resistance. And the next thing is actually that something good for Bitcoin's long-term health is like the security budget problem of Bitcoin. So the Bitcoin fees get halved every 4 years, and after some point there won't be any fees, Bitcoin fees issued to the miners, and they will solely rely on the transaction fees to keep mining the chain. And at that point we need transactions that will basically make the blocks full, so that they pay a lot of fees to the miners, so that miners are still incentivized around their hardware. And that will happen also with rollups, because with rollups you have this thing where you send all the transactions in a compressed form to the L1, so that you are still very aligned with L1, paying most of the fees to the L1. But at the same time, users simply share the fee between them, so that it is not as expensive as on the L1, but still it benefits the L1. So these are the major, basically, reasons that I'm betting ZK rollups on Bitcoin.
Mm-hmm. So Bitcoin has all these amazing properties, but Bitcoin is extremely hard to work on, just like with in general, its community, its code. Why, can you talk about the origin story of Citrea and sort of why you guys are so stubborn and like set on Bitcoin with ZK rollups?
Yes, so initially we co-founded our company more than 2 years ago. And initially we actually built privacy on EVM chains. On Ethereum we built a couple of privacy protocols that's been live today. But together with ordinals, we decided like we should take a look into Bitcoin, because previously we were looking into Bitcoin, but we couldn't find anything to build because the script is very limited, and all you can build is basically a simple wallet maybe. But with ordinals, we realized now there's a new playground for developers to build something, and we built one of the first wallets that support ordinals, BRC20s and other token protocols on Bitcoin. And while building that wallet, we realized, okay, if we can build, let's say, BRC20s, then we can actually build a DEX for BRC20s or lending borrowing protocol for BRC20s. And we realized we can also use ZK to enable most of these features. But eventually what we are building become too complex, and it was actually looking really like a rollup on Bitcoin. we decided to build applications, but it became a huge infrastructure project because we have to build everything from scratch on Bitcoin. And we said, okay, instead of building that, let's try to build EVM on Bitcoin so that other developers can simply port all the existing applications at once and they will be running on Bitcoin so that no one has to build all the infrastructure just like we are doing right now. We have been building this product more than 1.5 years ago. We started building it. It's still work in progress, still on testnet. We are not live on mainnet yet. Yeah, it takes time. The code, like you said, is extremely hard because Bitcoin is limited. There are a lot of bugs in the code base that prevent some of the stuff that we want to do. And the second thing is obviously community. But I think that's changing like very fast actually. Especially after ordinals, now there's a new wave of developers and users coming to Bitcoin, and they're also stakeholders in Bitcoin's consensus and like where Bitcoin is heading towards. And basically the culture is changing more open, like to a more open culture in Bitcoin. And once we started building rollups on Bitcoin, no one knew about rollups, like very few people. But we have been talking about this on podcasts, on like articles, we have been releasing documentation, code base. Now actually like some of the even OG Bitcoin developers or like advocates, they know about rollups. And even though maybe some of them don't like the rollups, they still talk about rollups, which is a good thing. Means that we are now like having more awareness about this technology in Bitcoin community.
Mm-hmm. So one question is, so Citrea is trying to be a ZK rollup on Bitcoin that is verified on Bitcoin, uses Bitcoin DA.
Yes.
What's your opinion on sort of Bitcoin adjacent projects, restaking, side chains, trust minimized bridges? But why did you decide to take the route on sort of pure Bitcoin, only Bitcoin, sort of have this, I guess, Bitcoin maximalist sort of opinions, but with rollups on it? Can you just explain that whole space?
It's actually very connected with my first argument, which is security and the security budget of Bitcoin. So let's just go over the examples you give. One is like the restaking protocols, for example, like Babylon. So the idea there is you can use BTC assets, not the Bitcoin network actually, BTC asset to secure some site system. And that asset security is like, obviously Bitcoin has the biggest market cap in the total crypto, like even more than I think 60% right now, its dominance. But that security is still not the same as the network security. It simply says that Justin Sun can come here like and deposit 50 Bitcoin and manage all the site systems because it's just pure how much Bitcoin you hold. But the hash rate is something more different than the BTC as asset security. And those systems that's built with Babylon cannot inherit most of the stuff. They can bootstrap very good economic security for their chain or like site system, but they cannot have this censorship resistance guarantee or reorg resistance guarantee. Maybe they can have the reorg resistance, but not censorship resistance or not double spend guarantees. And that's the reason simply. They are good systems, definitely there are trade-offs, so they are much more cheap to construct. So there will be definitely use case for these, but it is not the same with rollup. And the same thing with sidechains as well. They've been around since 2014. There was Liquid sidechain, Rootstock, Stacks, now a couple more are coming. And basically the idea is they're fully separate chains that send some minimal data to Bitcoin to simply basically checkpoint their state into Bitcoin, but they are not putting all the data to Bitcoin or they are not having any proof of the validity on Bitcoin. They simply send, let's say, a block hash or Merkle root, which gives you a reorg resistance, but it doesn't give you any other property. And once you want to construct a bridge to these site systems, you have to have some kind of multisig. Because Bitcoin doesn't recognize your chain, and Bitcoin doesn't have any proofs on it to verify for your side chain. So that you have to trust some kind of multisig's majority, let's say 3 or 5 multisig, to move your Bitcoin from Bitcoin to this sidechain. But on rollups, the main advantage is everything you do is on Bitcoin, like the data, like the ZK proof. And together with BitVM, which is a new paper came out last year, actually means that if you have all of these data on Bitcoin, you can actually verify that proofs on Bitcoin in a trust minimized way. So this means you only need one honest person in the world to verify that ZK proof, and you don't need the majority of the multisig, you don't need any other economic security than the Bitcoin network itself. That's why we choose to build a rollup, because we think Bitcoiners are caring about the security. And all of the stuff that's happening on Ethereum with WBTC is no different than most of the side chains right now on Bitcoin. And there's clearly no demand for that kind of side chains. And the second reason is obviously the security budget problem, where we are the most aligned Bitcoin layers, you can say. We post all the data, we post all the proofs so that miners get majority of the transaction fees, instead of there is now an additional economical layer that you should distribute the value.
Mm-hmm. So restaking sort of gets, I guess, the properties of the asset. Mm-hmm. So it's a large asset. And bridges are sort of multi-sigs, and side chains have timestamps, but rollups on Bitcoin using Bitcoin DA sort of get all of that.
Yeah.
My question is on the constraints of DA. How much transactions can you really put on a Bitcoin ZK rollup?
Yeah.
Sort of, yeah. How expensive is it going to be?
So the throughput of Bitcoin is basically there are 4 megabyte blocks approximately every 10 minutes. So this is much more smaller than Ethereum. Even Celestia, Avail, like all the DA layers, they are even too big. But even Bitcoin's DA throughput is lower than Ethereum, which means you can definitely put less transactions on Bitcoin. What we did smart with building a ZK rollup is, unlike optimistic rollups, in ZK rollups you don't need to post full transaction data. You can basically compress them in a form of, let's say, state diffs, it's called in the technical jargon. And state diffs basically means that you execute a transaction and you only care about the change in the storage system that transaction did. You don't care about the transaction's input data, because you already verified the transaction in ZK proof. You only need the change in the state to ensure data availability is happening on Bitcoin. And this gives us lots of compression, because let's say there's a Uniswap pool on Citrea. I do a trade, you do the trade, and a couple more people do trades in the same pool. Only the initial state and the final state is written into Bitcoin, because all the intermediary states, they are actually proved with ZK, so that you don't need that data to verify these transactions. You only care about the input state and the final state. So that definitely gives us a lot of compression. We are still working on some additional techniques, but in its current form, doing a Bitcoin transfer on Citrea is 15 times cheaper than doing it on Bitcoin. And with the future things we are working on, it's called full state diffs, then that will become lower and lower. But right now it's even 15 times. And the other advantage is basically you get all the VM capabilities. Now you can do swaps on Bitcoin, and you cannot do that AMM swaps on Bitcoin natively. So there is no comparable gas cost for that. But obviously it will be not as cheap as Ethereum rollups or Celestia rollups. It will be definitely more expensive than those.
Mm-hmm. Also, let's get into, so Bitcoin originally wasn't a DA layer, so you could talk about how Bitcoin is able to provide DA, sort of the whole ordinals deal, and sort of those security assumptions.
Yeah. So technically, all the blockchains are DA layers. So any blockchain that you can put some data is a DA layer. And for Bitcoin, these were transactions. So in transaction, for example, there was some opcode called OP return. It still exists. And that OP return back in those times, I think, were allowing 40 bytes of data to put into Bitcoin. And there was protocols called, let's say, colored coins, Omni, Mastercoin, it was called back in days. They were using Bitcoin sort of DA layer, because they were putting identifiers in that OP return opcode, which allows 40 bytes. And it's upgraded to be 80 bytes right now, but it is still too small to put anything meaningful. The major thing was in 2021, there was an upgrade called Taproot, which allowed a transaction to be as big as the block. So this means you can have a single transaction and it can take up to 4 megabytes. This is the one thing that advanced to Bitcoin to become a more suitable DA layer. And the second thing with ordinals, Casey, basically the inventor of ordinals, realized that in Bitcoin script you can have a script trick and you can put some data into that script which is never interpreted, so it doesn't make transaction invalid, but it's still written into history of Bitcoin, and that basically enabled the ordinals. And after that, we see a bunch of inscriptions are coming to mainnet. Taproot wizard inscribing 4 megabyte image into Bitcoin by basically doing this trick. And after that, Bitcoin become much more suitable DA layer than it was previously, because you have to do this very limited space and you have to send a bunch of transactions to actually do it. And right now it is just like, it's cheap because it uses Taproot transactions, and it's also as big as 4 megabytes per 10 minutes.
Mm-hmm. I have a question about the sort of trust assumptions around that.
Yeah.
So that's dependent on Taproot. And so the data is being stored on Bitcoin, but it's not on the sort of UTXO side. It's on like that.
No, it's on the
Taproot.
UTXO side. Taproot is just like the name of the soft fork. And in Bitcoin doesn't hard fork. Bitcoin soft forks. This is unlike Ethereum, for example. So this means when an upgrade happens, there is another script version or transaction type added into Bitcoin, and Taproot is just one of them. So it doesn't change any trust assumption in Bitcoin. It is just like enabled in Bitcoin. The data that you send is still stored in UTXOs. So as trust assumptions, doing one transaction on Bitcoin by basically sending Bitcoin from my wallet to your wallet has the same trust assumption with putting a ZK proof and data into Taproot transaction and spending that UTX. So there is no additional trust assumption added by basically posting data versus just doing a native transfer.
Mm-hmm. My question is around the idea that it uses Taproot, but only around, 40% of the nodes run the soft fork?
Yeah.
And so what's your opinion on sort of that security difference? Because you have sort of the 40% of the network, or I think it's around 44, or like most of the network runs the soft fork, but some of the network doesn't. So like, what do you think about those DA trust assumptions?
So the good thing about Bitcoin is, like I said, it moves with soft forks, not hard forks. And like you said, for example, some of the nodes didn't upgrade their nodes to the latest version that runs Taproot. So what they see is basically there's a transaction coming, and there might be some additional data, but they don't see that data, or they don't interpret that data, and they just assume that it's correct. But that basically gives, because there's a commitment in the block, basically Coinbase transaction of the block put by miners, so that even though they don't actually see that, it's getting validated because it's put there, and all of the rest of the nodes actually validate it. But in terms of data availability, yes, you can assume that only, let's say, 45% of the nodes store that data, or the data made available to them. But even that's the case, I think the current node number in Bitcoin is around 50,000. And that basically gives you, I think, around like 20,000 full nodes that is downloading every single data published on Bitcoin, which is, I think, still higher than any of the L1s, even with some of the light nodes available L1s.
Mm-hmm. Yeah, I would agree on that. I just wanted to get your take on sort of the soft fork side of things. Can you give some more tangible sort of numbers on like how much it would cost to like submit a transaction? Can you go through like sort of a simple trade, a simple lending protocol, and sort of NFTs compared to all the other ecosystems?
Yeah.
But also, like you said, transfers would be cheaper on Citrea, and ordinals would also be cheaper.
No.
Explain through all that.
So the thing is, I cannot give exact numbers because we are using state diffs. So there's a huge difference between, let's say there's a Uniswap trade on Citrea, and that pool is only used once in that batch, versus that trade is used 10 times in that batch, which means that those transactions will have 10 times more fee than if the pool used 10 times more. So there is no tangible number that I can give you, because every transaction costs a different fee that's independent from the Bitcoin fee rate or the rollup fee rate. That's fully dependent on the usage of the rollup. So there is no way of like giving exact numbers for gas fees, but for estimates, I think we can say that the fees will be like in between Ethereum rollups and Ethereum mainnets, and will be probably more close to Ethereum mainnets than Ethereum rollups. So you can assume that if you do a DEX trade and it's like a calm day in like calm hour, then the transaction fee will be more close to ETH-L1 versus ETH-L2s. So that's the only way I can give kind of like the approach to the fees, because like I said, it really depends on the usability, like how many people using the same storage slot in the rollup in that batch. So it's very probabilistic. But for transfers, like I said, for example, I think today, I don't know the exact set V-byte rate on Bitcoin right now, but for transfers, it is very simple because there's a like less probability that storage slot will used more than once, that you can think the fee will be basically 15 times cheaper than doing the same thing on Bitcoin L1, independent from the fee rate of the L1 because of the compression that we have. For ordinals, what I mentioned was something else. In Taproot upgrade, the additional storage that it added to Bitcoin cost basically the quarter of the rest of the quarter fees compared to the rest of the blocks. So it's 4 times cheaper. Putting data on Bitcoin is 4 times cheaper than if we did before Taproot. So that was what I meant to say.
Mm. Can you talk about, so we talked about the DA side, can you talk around sort of the proving and ZK stuff and the constraints of just like everything?
Mm-hmm.
Yeah.
So on Citrea, we are building a type 2 ZK EVM, which means it is fully EVM compatible, so that all of the existing applications can simply port their code base, change the RPC URL and deploy. They don't have to do retesting. They don't have to do rewriting. Almost every opcode is activated, but none of them are changed. So it's fully compatible. And on the proving side, we are utilizing RISC-0 mainly, and we have a multi-prover implementation for SP1 as well. So our code base is written in Rust, fully in Rust, and our EVM implementation is also in Rust, which borrows a lot of stuff from paradigms REVM and REIT. But that code base is basically goes proving using RISC-0 and SP1, mainly RISC-0 for now. SP1 is not activated, but on mainnet we want to activate it for multi-proving. For right now on testnet, we are basically utilizing RISC-0 to generate the ZK Stark proof from our EVM code base, and that Stark proof is wrapped into Groth 16 to make it smaller and verifiable on Bitcoin L1, and that proof is posted on L1 together with the state diffs that is resulted from that batch.
Mm-hmm. And so I hear there's sort of a constraint of size to put these proofs on chain. Have you guys hit that? How big are these proofs? So go for it.
So the proof itself, the Groth 16 proof, is I think 280 bytes, which is very small compared to the 4 megabyte limit. But the state diff has to be smaller than 4 megabytes so that you can put that state diff into Bitcoin in a single block. If it's, let's say, 5 megabytes, you cannot send that transaction to Bitcoin. Miners won't be mining that because it invalidates the block size limit. But we have a trick there basically implemented. Our ZK circuits are smart, I say, so they can divide the data into two and post it in two pieces, and later we can merge that proofs together into one so that we don't violate Bitcoin's constraints. So let's say there was a sequencer already like acts pessimistic, so always checks the state diff size, and whenever it's close to being a 4 megabyte, it sends the batch to Bitcoin without waiting anymore. But sometimes there may be, let's say, multiple transactions coming in a single block so that sequencer cannot estimate. And if that's the case, basically sequencer can send a single commitment, but our prover can make something smart and basically take the commitment, prove the half of it, send to Bitcoin, and then prove the rest of it and send to Bitcoin again in two different blocks so that we don't violate the 4 megabyte block size limit of Bitcoin. We worked a lot on our prover implementation. Maybe like together with the release of this podcast, there will be a blog in our blog as well, an article that we are working on how we made basically our prover smart than the regular provers. But yeah, we did a lot of stuff to overcome the limitations of Bitcoin.
And so you guys now, for Bitcoin, do you guys put the proofs in the DA layer and then also have Bitcoin sort of verify it as well, like compute the proof? Is that okay?
Yeah, so it's just like an Ethereum ZK rollup. Basically, there's this proofs and state diffs posted on Bitcoin regularly. But unlike Ethereum rollups, they don't get validated every time they post it. first we post them and they stay there. And after a couple of days, we aggregate them together into something called light client proof, which is basically a kind of aggregated proof or recursive proof of all the batch proofs. And that proof is getting verified in Bitcoin using something called BitVM. And BitVM is, maybe I can quickly explain what it is because it's a very new paper by Robin Linus. It's released last year. But the implementation become more and more complete this year together with the updated paper. And also now there's something called BitVM Alliance, which we are one of the founding members of it. And the Alliance is basically working on implementing BitVM in Rust to work on Bitcoin. Right now it's all in paper. Like most of the code base is actually done, but it's still not finished. Hopefully in a month or two it will be finished. And basically how it works is there's no multiplication opcode on Bitcoin. There is no like basically string complete opcodes on Bitcoin. It's very limited. So if you can try to, let's say, build a gross 16 verifier in Bitcoin script, it takes a gigabyte of script, which is impossible to execute in a block because it has to be smaller than 4 megabytes. So what Robin find out is, what if we can still build that script and divide that script into, let's say, 1,000 chunks? And the prover basically can sign every input and output of the chunk using Lamport signatures. And we can publish that off-chain. And whenever someone thinks that this proof is incorrect, they can simply find the incorrect chunk because there should be some chunk that's become incorrect. And then they can simply put that chunk into Bitcoin and execute, which the chunks are below 4 megabytes, so that you can verify the input signature, execute the chunk, verify the output signature. And then you can decide that if the proof is lying or not. So it actually gives the exact same guarantees as Ethereum ZK rollups because the verification happens on the L1. But it happens optimistically, so that unless there is a challenge, no proof is verified on Bitcoin and assumed correct. But if there's a challenge, then it's verified on Bitcoin and the malicious party gets slashed.
Yeah, because I did hear about the sort of 1 gigabyte size proofs which couldn't be verified on Bitcoin. Yeah. So you guys have a ZK VM, RISC-0, also maybe SP1, generate these proofs and then put them on chain and then aggregate them and then send it to BitVM in multiple pieces. You guys check the inputs, outputs, and then...
And if everything correct, nothing happens. Basically, there's 2-week time lock. And if everything correct in 2 weeks, then the state moves forward. But if one of the watchtowers thinks that, okay, this aggregated proof is actually incorrect, someone is trying to steal money from there, they can simply execute one of the chunks in BitVM on Bitcoin so that they basically break the time lock and prevent the breach from draining.
And so it has the ZK tech, but finality would be talk about the finality of it, because Bitcoin doesn't have finality, but ZK proofs prove.
So Bitcoin has like finality, but Bitcoin has probabilistic finality. So unlike Ethereum, Celestia, there is no signers that sign blocks to finalize. So what happens is in Nakamoto consensus, miners simply mine the blocks, and over the time, you think that they are hard to reorg as the time goes. And there's a widely accepted 6-block definition. Basically, after 6 blocks, you have to, like, the probability of that 6 block is reorged is, I think, like less than 0.1% or like something like that. So it's very low risk. And the finality here is basically once you send the proof with data on Bitcoin, that's actually finalized. You don't have to wait for the Bitcoin to verify the proofs, because in your full nodes, you can basically always watch Bitcoin, and whenever a proof arrives and 6th block is over of that block, you can simply pull the proof, verify yourself, and finalize your own state. So that's a common misconception, especially in Ethereum world as well. Optimistic rollups, for example, doesn't have 7-day finality. They have immediate finality because they dump all the transaction data on the L1 immediately and full nodes check from there. The thing that is updating is the L1 smart contract. Basically, the bridge has 7-day update periods, but the full nodes has immediate finality. The exact same thing happens here. If you are running a full node, then your finality is whenever the ZK proof arrives, which is like probably an hour or so, because ZK proof has to get generated. For the bridge, it's a couple weeks, because having this verification on Bitcoin is expensive and it requires a couple rounds of challenge response, so that you have to have this time lock for every 2 weeks. But that doesn't affect the finality. That only affects basically the updated bridge contract, which is not relevant for regular users.
Mm-hmm. I guess let's now talk about more about the bridge.
Mm-hmm.
So you can bridge Bitcoin from the, I guess now like L1 to a ZK-L2.
Yes.
Would this be the most secure Bitcoin bridge?
Yes,
and could you get this Bitcoin on the L2 and bring it to other chains?
Yes, so not other chains, but on Citrea, because if you try to, let's say, build a BitVM bridge to Ethereum, then you have to have like some kind of Ethereum Lite client verified on Bitcoin, which doesn't exist because Bitcoin doesn't know about Ethereum. But Bitcoin know about Citrea, because Citrea's all data is on Bitcoin. So I would say, like, we call our bridge Clementine. Clementine is the most secure Bitcoin bridge to a programmable layer. Obviously, once you deposit, let's say, to your Lightning wallet, it is much more secure because you actually hold all the funds yourself. But Lightning doesn't have any programmability, and it's basically a channel between you and someone else. So it's not comparable, I would say. But for among all the Bitcoin bridges, say TBTC, Rootstock Bridge, WBTC, CBBTC, this is definitely the most secure one among all of them. And the reason it is first the BitVM, which basically allows one-of-n trust assumption. As long as someone is honest, the proof is verified on Bitcoin. And the second is Citrea is built right on top of Bitcoin. So the Citrea Lite client proofs are trustlessly verifiable in Bitcoin.
Another question is, so all these ecosystems, sort of, I guess the big ones, start their own VM. So like Ethereum has the EVM.
Mm-hmm.
Why? I think there's a chance to sort of push a new VM onto the Bitcoin community. Like, it's pretty big. It could be well supported. Why the EVM? And is there any ideas of having a Bitcoin specific virtual machine?
I think like EVM is probably not the greatest VM in the world for sure, but it's definitely the most adapted VM in the blockchain space. So there was a Bitcoin sidechain, very old sidechain called Stacks, and they built their own VM called Clarity. And literally no one knows how to code in it. Like all the applications on Stacks is built by the Stacks company, because no one else wanted to learn that new programming language in a new VM that you don't know how it works, you don't know how the gets calculated, you don't know the syntax. There's no one in the world that can audit that code. So that's definitely will be an expensive experiment for us, and we don't want to do that. Like EVM is the most adapted smart contract. It is, even though like there are some security vulnerabilities that you can do, let's say reentrancy, you have to protect yourself from reentrancy, but still EVM smart contracts are the most protected smart contracts because they're actually tested, like they're battle tested in Ethereum and all the EVM chains. So that basically by building this type 2 ZK EVM, we can say that, okay, the Uniswap contract we know is battle tested. Like the Uniswap V2 been around for years. Now we can copy the code, paste on Citrea, deploy, and you will have the same battle tested infrastructure and code base running on Citrea. But instead we would build our own VM, then we have to get a lot of audits. We have to find people to learn our language and or learn our VM. Then we have to find auditors who can audit that code base, which is, Bitcoin doesn't have that much time. People are using WBTC, CBBTC, all the custodial solutions. They are putting their money into exchange and trying to borrow from there. So Bitcoin is going into somewhere like very custodial oriented. And if you also try to build a wallet and other stuff, it will delay a lot of stuff and Bitcoin become custodial in the end. So we wanted to go to market faster for applications and basically use the most battle tested VM in the world, so that we just choose the VM.
Mm-hmm. Another question is on sequencing. Mm-hmm. So could you just talk about sort of how you guys sequence Citrea?
So it's initially a single sequencer network that's run by basically the team. There's a single sequencer that gets the transactions to the mempool, and every 2 seconds we seal a block and send to all the full nodes. So the block times are 2 seconds. Block gas limit is I think 15 million, which is the half of 8 million. Sorry, I think the quarter of the like Ethereum mainnet. And hopefully in the future we have the plans for decentralized sequencing and then the proving. Just today I tweeted something about it as well. But yeah, so initially it's a single sequencer network with 2 second block times and 8 million gas limits. In the sequencing role, it's basically by priority fee. There's a mempool, and every 2 seconds, the block builder takes all the transactions, orders by the priority fee, and seals into block and sends it.
What's your opinion on base rollups on Ethereum? I mean, on Bitcoin.
On Bitcoin, hell no. Like on Bitcoin, definitely no. The Bitcoiners are like literally allergic to MEV. The only reason most of the soft forks are vetoed are because of MEV. No one wants to have like MEV on Bitcoin there. I think there's MEV on Bitcoin today because of runes, BRC20s. There are sniping attacks on listings and stuff. There's definitely MEV. But once you build a base rollup on Bitcoin, you literally mean that like all of the miners can do the sequencing so that they have incentive to MEV, reorg the chain and do MEV. So that's definitely not something anyone wants in Bitcoin world. That's the first reason. And the second reason is Bitcoin block times are 10 minutes. And there is no, like in Ethereum, there is this pre-confirmation thing where you can actually know that like who will be the proposer of the next lot so that you can do pre-confirmation and stuff. But on Bitcoin, it's probabilistic. You don't know who will mine the next block. They are just all competing. So you cannot basically auction your transaction so that you can have shorter block times. You have to have 10-minute block times in Bitcoin if you build a base rollup on Bitcoin, which no one probably wants to use a 10-minute block time rollup, which opens an MEV to the Bitcoin miners, and it will be expensive as Bitcoin. So I think it's not a good idea. But on Ethereum, I think it's an interesting experiment to see.
Wouldn't the counter argument to that be the centralized sequencer is now the only person who can sort of do the MEV stuff?
So in the single sequencer, there is only one party that sequence, which gets all the rights for MEV basically. There are some solutions to that, like TE sequencers. I think that was a recent research by Uniswap, Optimism, and Flashbots, that you can attest that you built the block based on some set of rules. So I think that's definitely great. It's like I don't like using TEs for security, but you can use TEs for this kind of attestation stuff, right? It doesn't affect the security of the rollup, but it definitely guarantees that as long as SGX chip is secured and the block building rule is correct. So I think that's one thing that we can enable. And the second thing is obviously the decentralized sequencer network. It doesn't open like the MEV doors because there is still a set of sequencers collectively signs the block and finalize. So Bitcoin miners cannot change anything. But decentralized sequencer obviously increases your resistance against censorship so that you don't have to fall back to the L1 all the times. And it also guarantees that your rollup will be more live because there's a high chance that a single machine can go down, but a collective go down is usually not happens.
So I feel pretty satisfied. I think I understand Citrea pretty well. Is there, what's been your guys' feedback from the Bitcoin community and like acceptance of Citrea?
So initially we started like in a very hard path. We said that, okay, we are building a ZK rollup on Bitcoin. And this was summer last year, I think around July. It was right after ECC that I came back. I talked with lots of friends and like get the idea, should we actually commit to do this full time and stuff. And then we simply said, okay, we are building a ZK rollup on Bitcoin. And everyone said, guys, you are crazy. Just like, if you want to build it, build on Ethereum because you don't need to do it on Bitcoin. You cannot do it on Bitcoin. Even some of the Bitcoiners said that, oh, it won't work on Bitcoin. Don't even try it. But I think over the time, we released a lot of educative material, including our documentation, fully open source code base, our blog, our Twitter. So we are basically trying to become the education hub for Bitcoin rollups. And that's basically a lot of Bitcoiners got interested into that idea. So whenever now, initially I was trying to talk about rollups with people, but they don't know about it. But right now in big Bitcoin conferences, there's panels and keynotes on Bitcoin rollups. I think last year I gave a keynote in like Bitcoin Amsterdam. My co-founders and I had a panel in like Bitcoin Asia, Bitcoin Nashville, all about rollups on Bitcoin. And this wasn't happening a year or two ago. So I think I can definitely say like the Bitcoin community is now accepting that there will be rollups on Bitcoin. But they're still on testnet, obviously, so that our basically awareness is much more smaller than the side chains or Lightning, I would say. But as the time goes, people understand that rollups can actually be helpful to Bitcoin scaling, getting more features, becoming more resilient to the future as the security budget problems goes away. And yeah, I think we are making a good progress. We are on the right track, I would say, but it is definitely a challenging thing to try to like bring some innovation to Bitcoiners that's actually originally invented in Ethereum.
Mm-hmm. I think we're going to wrap things up, but I want your take on, so you talked about sort of explaining to the Bitcoin community sort of this new potential. Can I get your take on sort of Ethereum's roadmap and sort of the current discourse around it and like the community not wanting to change or is even open to ideas? Can you just talk about that?
That's funny because like I know this podcast will release later, but yesterday night I had a tweet with one of the base rollup builders on Ethereum, like a thread with him, and I was saying that like the Ethereum is having its Bitcoin moment right now. In Bitcoin from 2014 to 2017 there was two major occasions. One is Ethereum's launch, and the second is the block size wars. And during those times, Bitcoin lost a lot of talent, right? This mainly Vitalik. Vitalik was the founder of Bitcoin Magazine, one of the oldest Bitcoin publications, and he founded Ethereum. So he left Bitcoin. I also tagged there Justin Drake. He was an OG Bitcoiner, and now he's a prominent Ethereum researcher. A couple more people. And on Ethereum, I think it's having the same thing, because after those things happened on Bitcoin, a lot of stupid people become stakeholders. And they think that they have a right to say on Bitcoin's future. I think on Ethereum now, the same thing happened. A lot of competing things happening on Solana or Celestia or some of the Altel ones and infrastructure projects, and Ethereum is losing some of its talent to these projects. As the talent goes away, a lot of, like I said, less prominent people become more and more visible in the community, and that may affect the Ethereum's culture, Ethereum's building culture, the roadmap, and all of the stuff. I'm not before 2 or 3 years ago I was really into it, but right now I'm just watching from my Twitter to see what's happening on Ethereum world. And I would say there's definitely innovation happening there, but it's a bit stealth because a lot of the development is leaked to other stuff. Like the Ethereum had this sharding thing for years. Now it's become rollup centric roadmap and become the dank sharding and then the data sharding basically by adding blobs. But at the same time now there are 3 or 4 other DA layers launched, and all of the projects are most of the projects, new projects, are using that DA layers. Because they were able to ship faster than Ethereum mainnet, which is natural because Ethereum is too big to act that fast. But yeah, it's still changing. But I'm still watching some of the developments because we learn a lot of the development stuff from Ethereum to implement on Bitcoin, mainly ZK rollups.
Mm-hmm. That was a really good take. Is there anything else before we wrap it up? Anything you want to shout out, talk about?
I think we talked about a lot of infra and technical stuff, but there's also the non-technical aspect of it. Still technical, I would say, but Bitcoiners are looking for applications. They right now have to use either custodial applications, put their Bitcoin into custodial application, borrow USD in custodial application, and try to spend that USD. And the second part is people has to use WBTC if they want to use Bitcoin and DeFi. And that needs to change. We are building the infrastructure to enable non-custodial and trustless Bitcoin applications. But we still need Bitcoin, still need app developers to build these applications on Citrea so that these people don't have to use custodial solutions. People can build Bitcoin-backed stablecoins, Bitcoin-backed loans, prediction markets, exchanges, DCA platforms, all of the stuff that you can build on Ethereum, you can build on Bitcoin, and the market is definitely way bigger than Ethereum. So there's definitely an opportunity for developers, and that's why, like, after our Series A from Founders Fund, Mail 11, like Eric Voorhees, Balaji, like all the great names, they supported the idea of launching us incubation program for Citrea, which is called Citrea Origins. So we simply work with prominent founders, developers to build applications on Bitcoin, which would enable non-custodial applications for Bitcoiners to use. So if any of the developers watching, listening this is like interested to basically launch something on Bitcoin markets, can definitely reach out to me. My Twitter is 0x_Orkun, or like our basically web page is citrea.xyz, so that they can simply reach out and we would love to talk with them.
Yeah. Thank you so much for coming on. Enjoyed learning about ZK rollups on Bitcoin. And I'm excited for sort of this new era, this Bitcoin renaissance.
Yeah, thank you for asking great questions and having me here.
Thank you.
Bye-bye.